right, in this video, we're going to talk about factoring out a GCF from polynomial expressions. Remember, factoring is the opposite of multiplication. So instead of putting things together, we're breaking things apart into their pieces. So today we're going to talk about specifically factoring out a greatest common factor. Now, you've seen greatest common factor in the past. It's been in a context like this, where a question will ask you to find the GCF of 24 and 18. And some of you, I suspect, already know that the greatest common factor of 24 and 18 is 6. Just in case you've forgotten, let's talk about how you would find that. So what I want to do is I want to find all the numbers that multiply together to get 24. I always suggest that students are systematic, so start with 1. So it's 1 times 24. 2 is next, 2 times 12. 3 is next, so 3 times 8. 4 is next, so 4 times 6. 5 is next, but it doesn't work. And then the next number we have is 6, and we already have it written down. So if I do it in order, I know I'm not going to miss any factors. And then if we find the factors of 18, we say 1 times 18. The next number would be 2. 2 times 9. Next number would be 3, so 3 times 6. The next number would be 4, but it doesn't work. Next would be 5, but it doesn't work. And then the next number we would get to is 6. We already have it, so we know our lists are complete. Now we just look for what do the two lists have in common. Now notice they both have a 2 in common and a 1 in common, and even a 3 in common. But the biggest thing that they have in common is a 6. So if we wanted to find the GCF of 24 and 18, we would say that the greatest common factor is 6. All right, so now this is what's new. Instead of just having the numerical parts like the 24 and the 18, I'm going to add in variable parts. So we know already if we want to find the GCF of my first monomial, 24x cubed y to the 4th, and my second monomial, 18xy to the 5th, we already know the numerical part of that GCF because it's the same numbers from example 1. So we know it's going to be 6 and then something. So let's just talk about the variable parts of that. Again, I think some of you will look at these and think, well, they both have this in common, and you can just go ahead and write that down. If it's not that obvious to you, then let's just think about a list of the factors. So x cubed would be the same as x times x times x, and then y to the 4th would be y times y times y times y. So then if we did x times y to the 5th, it'd be 1x, so x times, and then we've got y multiplied by itself 5 times. So now if we look at where the overlap is, just like here, we saw the overlap and we looked at the biggest thing that overlapped in those two lists. Here we want to do the same thing. So for the x terms, the biggest part that overlaps is just 1x. But for the y's, notice we've got 4 y's in both lists. So what we can say is that the greatest common factor for the variables would be x to the 1st and then y to the 4th. I want you to notice how that corresponds with these up here. I want you to notice we came up with the greatest common factor being x, y to the 4th. Notice for your x's, the smallest exponent you have on the x parts is a 1, and that's the greatest common factor in terms of the x variable. And then the smallest exponent you see for the y is a 4. So that ends up always being your greatest common factor of any sort of variable terms. So that's what we're going to be doing. What we're going to do is not just identify those greatest common factors, but we're actually going to factor them out or pull them apart so that instead of having one final simplified, in this case binomial, we'll have 2 factors. One of the factors in this case will be a monomial, and then one of the factors will be a binomial. So let's do this. So for example 3, I always ask my students, what do the 2 terms have in common? So first, make sure you recognize that 5x is one of your terms, and then that positive 15 is one of your terms. Hopefully you can automatically say, well, the thing that those 2 terms have in common is a 5. Remember, factoring is the opposite of multiplication, so we're dividing. So you want to ask yourself, well, what would you have left if you divided 5x by 5? And hopefully you're able to say you would have an x left. And then for that second part, what would you have if you divided a 15 by 5? And hopefully you'll see that you have a 3 left. Notice what we've done is we've undistributed a 5. If we were to redistribute, if we multiplied 5 times x and 5 times 3, notice what we would get, 5x plus 15. So we're just doing the opposite of multiplication, and that's just technically called factoring. Okay, for example number 4, let's look and see what all those numbers have in common. So I always look at the numerical parts first, and I notice that for 15, 25, and 5, the biggest numerical factor, the greatest common numerical factor is a 5. And then remember, for your variable terms, you just choose the smallest exponent term. So in this case, it's x squared. So that becomes my greatest common factor. So I'm going to factor out a 5x squared from every term. Factoring is the same thing as division. So you can always think of it like this. Ask yourself, what is negative 15x to the 6th over 5x squared? Negative 15 over 5 is negative 3. And then x to the 6th divided by x squared. Remember, we subtract exponents. It's going to be 3x to the 4th. And then if I divide that second term by 5x squared, 25 divided by 5 is 5. X cubed divided by x squared is just x to the first. And then finally, if we divide that last term by 5x squared, notice it's the same on the numerator and the denominator, so we end up with just a minus 1. Now, I just want you to notice here, the biggest term that's left in that second factor is negative. So I usually suggest that my students go ahead and factor a negative out, so that with this leftover trinomial, that biggest term, the term that has the biggest exponent on it, make sure that that one is positive. This would not be wrong. I just would suggest moving to the second one. So if we continue this, we would end up with a positive 3x squared minus 5x and then a plus 1. And you'll see later on down the road why that's preferable to having a negative 3x to the fourth. Okay, next one. Let's look at our numerical terms. 12, 28, and 20. What's the biggest numerical factor or the greatest common numerical factor? Hopefully you're saying 4. Now if we look at just the variable parts, we want to choose the variable that has the smallest exponent, so that's just an x to the first. Now we're thinking, okay, if I factor out or divide out a 4x from 12x to the fifth, hopefully you can see that that's going to have a 3x to the fourth left. Then if we do the same thing to 28x squared, 28 divided by 4 is 7, x cubed divided by x is x squared, and then negative 20x divided by 4x is going to give us just a negative 5. And we're finished. Again, remember you can always check yourself by remultiplying. So if we were to distribute this back, if we did 4x times 3x to the fourth, we would get 12x to the fifth. And if we did 4x times 7x squared, we would get 28x to the third. And if we multiply 4x times negative 5, we do in fact get negative 20x. So that's a good way to check your factoring, is by going at the end and remultiplying everything back together. All right, and then finally, a little bit messier, but don't let the multiple variables mess you up. So again, we're going to find the greatest common factor for the numbers. So 12 and 28 both have a 4 in common. X to the fifth, let's look at the x's. We want to choose the smaller exponent x, so we're going to go with an x cubed. And here, we've got a y squared and a y cubed, so we can factor out a y squared. Now ask yourself, if you factor out a 4x to the third y squared from that 12x to the fifth y cubed, what's left? Well, 4 times 3 would give you 12. X to the third times x squared would give you x to the fifth. And y squared, this one right here, y squared times y would give you y to the third. And then if we go to that second one, it's a 4 times what to give you negative 28, and it would be a 4 times negative 7. And then we want an x to the third, which we've already got an x to the third right here, so it would just be a 1. X to the third times 1 is x to the third. And again, the same thing, y squared times 1 is y squared. So our second term in that binomial factor is a minus 7. All right, so before we move on to the back of this page, I want to show you a different way of just visually looking at these common factors. One thing I could have done here with 5x plus 15 is I could have written this as 5x could be rewritten as x times 5, and 15 could be written as 3 times 5. Notice what happened is we have a common 5, and what do we do with that? We undistributed it so that it came here, and then what was left was an x plus 3. So think about that for a second if you need to. And let's just do one last kind of visual example of this. I could have rewritten 12x to the fifth plus 28x cubed minus 20x as 3x to the fourth times 4x, 7x squared times 4x again, and negative 5 times 4x. Notice what happened is the 4x gets undistributed. That's why it's out front right here. And then what's left is a 3x squared plus 7x minus 5. So keep that in mind, because that concept is what's going to help us build on the next topic. And it's called factoring 4-term polynomials by what's called grouping. So far we've only factored out. So notice when we factored out a GCF here, we factored out a 5. That's a monomial. Right here we factored out a 5x squared. That's also a monomial. Right here we factored out a 4x. That's a monomial. And here we factored out a 4x cubed y squared, and that is also a monomial. But here, when we start factoring by grouping, instead of only factoring out monomials, it's going to allow us to factor out binomials. Okay, so here's a process. So first thing you always want to check for is if there's a GCF that you can factor out of everything. After you've done that, what you're going to do is you're going to group the first 2 terms and the last 2 terms. Then you're going to find just the GCF of the first group and factor it out. Then you're going to factor out the GCF of the second group. Sometimes you're going to have to factor out a negative, and you always want to factor out at the very least a 1. And then finally, after factoring, if the remaining binomial in each group is the same, you're going to factor it out as the GCF of each group. Okay, so I'm assuming that probably didn't make a whole lot of sense yet, but stick with me and I think it will. So let's do this. We've got 4 terms. We've got this term, this term, this term, and this term. So we're dealing with a 4-term polynomial. The first thing we always check for is a GCF. So if we have, like for those 2 terms, there's a GCF, but there's not a numerical GCF for all 4. And notice 3 of the terms have an X on them, but not all 4 terms. So because of that, we're going to go ahead and factor using the next step in the process. So always check for a GCF first, but know that sometimes there's not going to be a GCF other than 1. So now, because we have 4 terms, another procedure we can use is called factoring by grouping. So we're going to group the first 2 terms, so 15x squared, or 5x squared and 15x, and the second 2 terms, 2x and plus 6. And then we're going to factor out the GCF of the first 2 terms. So we've seen something that looks similar to this on the first page. Numerically, the GCF is a 5, and then the variable GCF is an x. When we factor out a 5x from 5x squared, we're left with an x. And when we factor out or divide 15x by 5x, we get a plus 3. So think about that, and if you need to redistribute this just to check yourself, do that until you're really comfortable with this. For the second group, we've got 2x plus 6, and our GCF of those 2 terms, just that second group, the numerical GCF is 2, and we don't have a variable GCF. So if we factor out or divide 2x by 2, we're left with an x. And if we divide 6 by 2, we're left with a positive 3. And then I want you to notice what those 2 things have in common. They both have an x plus 3 in common. Just like on that first page, those 2 terms had a 5 in common. And those 3 terms had a 4x in common. It doesn't matter if what they have in common is a binomial. You can still factor it out as a GCF. So what are we going to do? We're going to factor out an x plus 3. So we'll have x plus 3. And if I factor or divide that first term by x plus 3, notice what's left is a 5x. And if I divide or factor out an x plus 3 from that second group, notice what's left is a plus 2. And now we've got that polynomial completely factored by using grouping. Okay, if you felt really good about that, see if you can pause the video and try example 8 without me, and then come back and check your work. So let's go ahead and look at this polynomial for example 8. Let's first see if we can factor a GCF out of everything. Notice numerically, none of the numbers have anything in common other than 1, and there's not an x on that last term, so we can't even factor out an x. So we have 4 terms, so we can try to factor by grouping. I'm going to group the first 2 terms and the last 2 terms, and then find the GCF of each group. So for the first group, so GCF of 3x squared and 12x is going to be a 3x. If I factor out a 3x from 3x squared, I have an x left. If I factor out a 3x from 12x, I get a plus 4 left. Now that second term, I want you to notice that both of these have minuses on them. So generally speaking, if you see some negatives in that second group, or in any of the groups for that matter, it's usually a good idea to start off by factoring out the negative with the greatest common factor. So notice GCF of 8x and 32 is actually 8. Because we have negatives on both of those, I'm going to go ahead and factor out a negative 8. Now if I factor out a negative 8 from negative 8x, I end up with a positive x left. And if I factor out a negative 8 from negative 32, I end up with a positive 4. And then notice what we have. We have a common binomial factor that can be factored out, so we can undistribute that x plus 4. So we'll have an x plus 4 for one of our factors. And when we factor out an x plus 4 from that group, we just have a 3x left. And when we factor out an x plus 4 from that second group, we have a minus 8 left. And now we factored our 4-term polynomial fully. All right, next. We want to check for a GCF from all of the terms. We don't have one, so we're going to factor by grouping. How do we know we're factoring by grouping? Because this polynomial has 4 terms. And if it's got 4 terms, that's what you want to start off trying. So we're going to group the first 2 terms and the second 2 terms. We're going to find a GCF of the first 2 terms. My numerical GCF is a 12, and my variable GCF is going to be an x squared. Then what's left? If I factor out a 12x squared from 12x cubed, I'm just left with an x. If I factor out a 12x squared from 24x squared, I'm left with a 2. Now, for that second group, I want you to notice, a lot of students would say there is no GCF there, but everything has a GCF because everything can be divided by 1. So what we want to do here is we want to go ahead and say that this is plus 1 times x plus 2. Why do we do that? Well, think about this. Now we've got a binomial common factor there, and if we had left this part blank, then that might cause some confusion as to what the final factors were. So I go ahead and have students write that 1 as as a GCF of the second group. So go ahead and put at the very least the number 1. So now we'll go ahead and undistribute this x plus 2. And then what's left, if we factor out an x plus 2 from the first group, we have a 12x squared. And if we factor out an x plus 2 from the second group, we have just a 1 left. Now, if that were just empty, remember factoring is the same thing as division. And if we did x plus 2 divided by x plus 2, we would still get 1. But again, it's a lot of times really confusing for students if they don't have anything written there. So go ahead and write the 1. All right, and finally, example 10. This is one where we have more than one step for factoring. So notice if we ask ourselves if there's a GCF from all 4 of the terms, there is one here. We can actually factor out a 2x from everything. Now, I tend to want to put a bracket here just to use as a grouping symbol to set everything off. So you don't have to, but I just have the habit of doing that. Now, if I factor out a 2x from 12x to the 4th, I get 6x to the 3rd. If I factor out a 2x from negative 4x cubed y, I'm left with a negative 2x squared y. If I factor out a 2x from a negative 18x squared, I'm left with a negative 9x. And if I factor out a 2x from 6xy, I'm left with a 3y. So now we have broken one of our factors out of that 4-term polynomial. So now we're still dealing with a 4-term polynomial in the brackets, so we're going to try to factor it more by grouping. So I'm going to group the first 2 terms and the last 2 terms. Don't forget to continue bringing down that 2x because it's still one of our factors. Now we're going to ask ourselves, what is our common factor with 6x cubed and 2x squared y? Hopefully you're seeing that it's a 2x squared. Then what's left? If we factor out a 2x squared from 6x cubed, we end up with a 3x. And if we factor out a 2x squared from 2x squared y, we're just left with a minus y. And then for our second group, our numerical common factor, again, notice there's a negative right here, so I generally tend to go ahead and choose to factor out a negative here. So I'm going to say my greatest common factor here is a 3, but I'm going to factor out the negative of it. And now negative 9x divided by negative 3 is going to be a 3x. And 3y divided by negative 3 is just a minus y. And then notice what we have here. We have 2 common binomial factors, so we can undistribute those. So we'll go ahead and bring down our 2x. We can undistribute the 3x minus y, and then what's left when we undistribute those? We have a 2x squared and a minus 3, and that is our final factored polynomial. All right, I'll see you guys next time.